I have to factor 4x squared plus 20x plus 9. There is no GCF between 4, 20, and 9 other than 1. This almost looks like it could be a perfect square trinomial because I can do the square root of 4, I can do the square root of 9. So 2 times 3 is 6. If I double 6, I get 12, not 20. So it's not a perfect square trinomial. But it is a trinomial, which means I can try Korean method. So to multiply to get 4, maybe I could still try 2 and 2, but I know it's not going to be 3 and 3 because that didn't work. But maybe it's 9 and 1. So if I did 9 times 1, that would be 9 times 2 is 18, 2 times 1 is 2, that gives me my 20. So see, I didn't even have to try the Korean method with 4 times 1. I figured out it was 2 times 2. So I put my x's in. That's a positive 9, that's a positive 1, go straight across. So it factors into 2x plus 9 times 2x plus 1. One of the things you can do to check your answer to make sure you're right is pick some number for your variable. Like I like to pick 3. So I'm going to pick 3. I'm going to store it. So control variable keys. I said store above it. And I'm going to store that in the X key. Oops. So now every time I type in x, it's truly getting replaced with the value of 3. So I can type in the problem 4 and then x squared plus 20x plus 9. And I want to know, is that equal to the answer I just put in? So is that equal to 2x plus 9 times 2x plus 1? Okay, when I look at this again, the first time I typed it in, I didn't get the 20 in. I put in a 2. So when I typed it correctly, 4x squared plus 20x plus 9, I did end up with a true statement. It is 2x plus 9 times 2x plus 1. So tomorrow when you take your test, you can do this for every single problem. All you got to do is store the 3 once. You don't have to do that every other time. And now you can just type in your problem and your answer and see if you get true or false. And you'll know whether or not you're right or wrong. Use that to your advantage. Okay, for number 12, I don't like to factor with a negative on my squared term, so I will divide out a negative 1 so I don't have to deal with that negative sign to begin with. So I'll pull out a negative 1, which means that all my signs change. So I have a positive 5x squared, a negative 2x, and a negative 3. So now I know if I'm completely factored, I got to check the trinomial inside the parentheses. There's no GCF. So I can do Korean method because it's a trinomial. So the only thing I can multiply to get 5 is 5 times 1. Then I have to multiply to get a negative 3. Well, maybe I could try a negative 3 and a positive 1. So that would be 5. That would be negative 3. That adds up to positive 2. So I'm close. Let's switch the signs. Make that a positive 3. This a negative 1. So that's a positive 3. That would be a negative 5. And then that adds up to a negative 2. So that factors into 5x plus 3 and 1x minus 1. But you can't forget that in the very beginning you took out that negative 1. So you have to put that back on. Okay, 8x squared plus 18x plus 7. Is there a GCF? Between 8, 18, and 7, all they can be divided by is 1. So that means I need to try the Korean method, because it's a trinomial. So I can do, let's see, I can do 8 times 1, I can do 4 times 2 to get 8. I'm going to start with 4 times 2. The only thing I can multiply to get 7 is 1 and 7. So 7 and 1. So if I add up 2 times 7, I get 14. 4 times 1, I get 4. I got it on my first try. So put your x's in. So it factors into 4x plus 7. And 2x plus 1. And now I double check these parentheses. There's nothing that can come out of 4x plus 7. There's nothing that can come out of 2x plus 1, so I'm done. Number 14, is there a greatest common factor between 10, 13, and 3? Nope. So then, since it's a trinomial, I know I do Korean method. So to multiply to get 10, I can do 10 and 1, or I can do 5 and 2. I'm going to start with 5 and 2. Only thing I multiply to get 3 is 3 and 1, but it's got to be a negative 3. So maybe it's a negative 3 and a positive 1. So if I try that, I've got 5 and negative 6. That adds up to negative 1, so that didn't work. If I switch the signs, all that would give me would be a positive 1. So let's switch the numbers around. Let's put the 1 on top and the 3 on the bottom. So if I go back the other way, put a 1 here and a 3 here, but one of them has to be negative. Maybe I'll make the 1 negative. So 2 times negative 1 is negative 2. 5 times 3 is 15. If I add those together, there's my positive 13. So put your variables in. So I've got 5x minus 1, and I've got a 2x and a positive 3. And there's no GCF between 5x minus 1. There's no GCF between 2x plus 3. 6x squared minus 23x plus 15. No greatest common factor between 6, 23, and 15. So trinomial means I can try the Korean method. So I can do 6x could be 3 and 2, or it could be 6 and 1. 15 could be 1 and 15, or 5 and 3. I know I can't put the 3 here, because I can't put a 3 next to a 3. They would have a common factor, so I'm not even going to try that. So maybe I could try 5 and 3. So if I did 5 here and 3 here, I got to multiply to be a positive, but I got to add to be negative. So I know both signs have to be negative. So that would be a negative 9. That would be a negative 10. That would give me a negative 19. So that didn't work, and I can't try it the other way, because I can't put 3 and 3 together. So what else can I multiply to get 15? Well, I could try 1 and 15. So I can't put the 15 across from the 3 again, because that would give them a common factor. So all I can do is put it like this. I know they both have to be negative. That'd be a negative 2 and a negative 45. That adds up to negative 47. So that didn't work. So I've tried every possibility that I had for 3 and 2, 1 and 15. So if it's not 3 and 2, it must be 6 and 1. So let's try 6 and 1 with this. So if I try a 6 and a 1, well, I can't put, if I try 3 and 15, I can't put 3 across from the 6, but maybe I could put the 5 here and the 3 here. I know they both have to be negative. So 6 times negative 3 is negative 18. 1 times negative 5 is negative 5. If I add those up, there it is. There's my negative 23. So this took me a few more tries, but I eventually got it down to 6x minus 5 and x minus 3. And there's no greatest common factor between 6x and 5, and there's no greatest common factor between x and 3. Okay, number 16, no greatest common factor between 18 and 77. So I've got to start my Korean method again, because it's a trinomial. So 18 could be, oh, I got a lot of tries this time. 1 and 18, 2 and 9, 3 and 6. So I'm going to try 3 and 6 to start with. So if I do 3 and 6, well, I can't put an 18 across from a 3. I can't put an 18 across from a 6, so that won't work. If I tried 2 and 9, well, I can't put the 9 across from the 3, and I can't put the 2 across from the 6, and I can't put 9 across from the 6. 3 and 6, I can't put 3 across from 3 or 6 across from 3. So 3 and 6 I don't think are going to work. So I eliminated that. Let's try the 2 and the 9. So if I tried 1 and 18, I can't put 18 across from the 2. I can't put 18 across from the 9. What about 2 and 9? I can't put 2 across from 2. I could put 9 across from 2 and 2 across from 9. Maybe this will work. I got to multiply to be a negative and add to be a negative. So one of the numbers has to be negative and one has to be positive to multiply to be a negative 18. So I'm going to try a negative 9 and a positive 2. So that would be a negative 81. That would be a positive 4. There's my negative 77. So I got it. So it's 2x minus 9, and it's 9x plus 2. So that took a little bit of work.